So yes, as I was just telling you, and I just asked some of the students what's the difference between a smartphone and a GM counter. So, but unfortunately, you are not able to tell me the difference. You see, in a way, you can call a smartphone a detector as well, broadly speaking, since it is detecting the touch of our fingers, skin, and then there is a response from it as well. But in nuclear physics, what we mean by detectors is that those type of instruments which can not only detect nuclear radiation but also from it we can get some sort of information which can be accessible to human perception, and from there we will be able to get information about the nuclear radiation. What type of information? Various properties of nuclear radiation. What charge is it? What does it have any mass? What energy is it? Does it carry? What momentum is it? Most importantly, which direction it is coming from? Okay, so many type of things are there. So what we are going to study in this first class basically is the general properties of radiation detectors. I think you can see this on your screen.
Yes.
Okay.
Yes, sir.
Fine. Okay. Now, you see, the history of both nuclear and particle physics, they have seen the development of many type of detectors, and in a way it is not unfair to say that nuclear physics and particle physics, these two subjects, the development that we have in these two subjects today is a result of the technological developments which has led to the development of more and more sophisticated radiation detectors. And because of these radiation detectors, we have been able to successfully extract information about atomic nucleus and various other even astrophysical phenomena as well. So radiation detectors have made a very great contribution to the advancement of science. Now you see, there are many type of detectors, but remember that all of them are based on the fundamental principle. And what is that? The principle is basically to transfer a part or all of the radiation energy to the detector. So basically the entire idea is like this. We have got a detector, some radiation is coming, and if it happens that this radiation just passes through this detector without interaction, then it does us no good. Then it means that this detector doesn't detect the radiation. So it will say that no radiation is present. We can have, only when the detector detects this radiation, then we will be able to get information from it. Now when I say detect, what I mean to say this thing? What I mean to say is that there is a transfer of a small part. Suppose this radiation carries an energy E. Then if some part of energy, say alpha E, is transferred as a result of the interaction in the detector, where alpha is less than equal to 1. Of course, when alpha is equal to 1, there is complete energy deposition, right? Then only we will be able to detect. The detector will be able to understand that someone has entered its active volume and it has interacted with the detector. Okay, and then the detector is being developed in such a way that as a result of this interaction, what will happen? We will get something which will be accessible in some form of human perception, and that something will be electrical pulse. Okay, so the result will be some electrical pulse or electrical signal, right? So this is the input and this is the output. So this entire game is about this, the detection thing, transferring and then detecting, and then after getting the signal, afterwards there are many various important steps where we analyze this signal. Okay, now let me go to the next slide. Okay, now regarding this transfer, you already know that charged particles, CP, I am writing in short, they transfer their energy to matter or detector. When I say matter, I mean detector. Of course, detector is made up of matter. Now, charged particles, they transfer their energy to matter through direct collisions with atomic electrons, thus inducing excitation or ionization of atoms. So, excitation and ionization of atoms, that is the reason. Okay, what about neutral radiation? Neutral radiation, how does it transfer? You see, neutral radiation, on the other hand, there is a two-step process. The first step, they must undergo some sort of reaction. First step is a reaction inside the detector. Okay, where some charged particles will be produced. Fine. And what will happen after the charged particles are produced? Then we will have this same above step repeating, and this is the way. So first step is charged particle production, and then the charged particle deposits energy by this old process of excitation and ionization of atoms. Okay. Can you hear me? Okay. Now you see, the form in which this converted energy appears, this depends on the detector and also its design. For example, the gaseous detectors. They are designed to directly collect the ionization electrons to form an electric current signal, while the scintillators, in the scintillator counters, both excitation and ionizations contribute to ionizing molecular transitions that finally result in emission of light. Similarly, in photographic emulsion, the ionization induces chemical reactions which allow a track image to be formed. Okay. So, actually, in a broad sense, you can say there are two types of detectors. One is of electrical type and another is of optical type. Now, in this course, at this moment, we will be mostly talking about the electrical type of detectors. Now, in this modern, let me go to next slide. Yes. Okay. So, we will be talking about mostly electrical type detectors. Now, what are these detectors? We know GM counter, ionization chamber, and so on, semiconductor detectors. Okay, even our scintillation counters, they are all of this type of detectors. Now, you see, in this type of detector, the information is transferred in the form of electrical impulses, and this has to be treated in electronic means only. So, the signal is treated by electronic means. Of course, here we are taking advantage of the great progress that has been made in electronics and computers in the past few decades. Now, so as I am saying, when I say detectors in this course, I'll be talking about these electronics and electrical type of detectors. Okay, any questions till now? Here you see I have talked mostly about neutrons only. Neutrons. It is this way that they interact. Now we also have gamma rays as radiation. And how do they interact with matter? We know the primary three processes through which gamma ray lose energy in matter is what? Photoelectric effect, then Compton scattering and pair production. So charged particle we talked about, the neutrons and then gamma rays. Okay, so this one I probably missed. Fine.
বলছি এই পুরো ভিডিওটা স্যার আপনি আপলোড করে দেবেন তো?
হ্যাঁ 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 হ্যাঁ। Okay, so you see, হ্যাঁ বলো
স্যার এক্সপ্লেনেশন গুলো একটু বাংলাতে বলবেন এগুলো?
No, you see, we are teaching in English. I will try sometime, but try to follow the decorum. ঠিক আছে? Fine. Now, the first.
ইংলিশটা ফলো করতে একটু অসুবিধা হচ্ছে।
না না ঠিক আছে, আমি তো আস্তে আস্তে পড়াচ্ছি। Okay, দেখো, the first. So I have given you a very basic. Till now, I have given you a basic general overview of detectors, right? Now, as I was talking in the very, I was telling you in the very beginning of this lecture, we want to discuss about the various properties, characteristics of detector in general. And then I asked you whether the smartphone can be considered as a detector or not. Of course, in a broad sense, it is a detector, but in the nuclear physics sense, it is not a detector. It is not detecting any nuclear radiation. So, the first property that we are going to talk about is sensitivity of detector. A good detector must have very good sensitivity. Now, what is sensitivity? The sensitivity is basically the capability of producing a usable signal. For a given type of radiation and energy. Now, let me give you again an example. Suppose I put a nuclear source, cobalt-60 source, near your smartphone, again smartphone. Now tell me, what will happen? Let me tell you that from outside the source, you will be getting predominantly 2 gamma rays. Others are there, but they will be just sealed inside the cobalt-60 source, the electron and other stuff. From outside the source, you will getting 2 gamma rays. One is of energy 1173 keV, another is of energy 1332 keV. Okay, so what will happen? What I want to know is that, can I call this smartphone a detector, a nuclear detector? Well, we have to see. The first thing that I have been talking is sensitivity. So, I have to check first that whether these gamma rays, they will be emitting everywhere. Of course, they will be entering the smartphone as well. Now after entering the smartphone, will we get any sort of usable signal which will tell me that indeed one gamma ray of energy 1173 has arrived or another gamma ray of energy 1332 kV has arrived? If the smartphone can do so, then I will say yes. Remember this important thing, I am saying usable signal. So even if it is just a small spike, it is good enough. But remember that it is not just only two gamma rays are out there. We have cosmic radiation, even the ceiling, all the floors near around you, the concrete, everything, they even have 40 potassium. Okay, 40 potassium, and that is also a source of radiation, background radiation. So radiation is everywhere, and they will also be entering the smartphone. And if from as a result of this 1173 I am able to get a very small spike, but that is quite close to the noise that I am getting as a result of all other radiation, then I will not be able to decisively say that indeed the 1173 or 1332 gamma ray has arrived, or I will not be able to decisively say that I am able to detect gamma radiation from cobalt 60. So I will say my detector is not sensitive. But remember, there is a catch. The catch is I am saying that at least it is able to detect the noise. Okay, the noise means a signal, but I want a usable signal, and this is a usable signal. Let me show you in a different graph. So I am getting this is level, this is your sort of noise. Okay, now this is just noise, or basically this is signal. You can say that this is signal. Of course it gives you information that something is entering, or it can be a result of electrical noise as well. It has got nothing to do with the radiation entering the detector. You have to check. But if as a result of the 1173 we get a peak like this, okay, now see, this is very much different. So you can identify this. Now we are moving on a field, and all of a sudden there is a very small plant over near the field. But from the far away also, if I ask you if there is a small plant or so, you will say no, I cannot see it, because the field and the plant sizes are the same. But there is a big tree, and you see, you can easily spot this tree. Same thing is happening. You see the signal, its height in this case, okay, the signal is so strong, you can say, or the energy deposited is strong and the detector is sensitive, that we are able to get such a signal, and this we can identify. So this is a usable signal. Right now what I am trying to tell you is the difference between no signal. So if I am using something, what will happen for the case of smartphone? You will not get anything actually. But if I use some other detector where I am getting an electronic noise or so, then also it is of no good to me. Only when I am getting something like this, where I am able to identify the source, which is the cobalt 60 source in this case, then only I will be able to say that yes, my detector is indeed sensitive to the radiation. But remember another very important thing, God is not that great to us, or you can say nature is not that great to us. Why? Because no detector can be sensitive to all types of radiation. and that also at all energies. এর মানেটা কি? What does this mean? এর মানে হচ্ছে, suppose I have got a good detector, suppose some A, it is able to detect gamma ray of energy 1173. Okay, I am getting a signal like this, good. Now suppose I use a different source where the energy is just 70 kV. Same, it is also a gamma ray, right? But unfortunately, if we use this in the detector, you will not see any signal. It will be just you will not see anything. So what does this mean? This means that your detector is good enough for energies of this range only, or so near this range. This is what I am trying to say. No detector can be sensitive to all types of radiation at all energies. And right now I am just talking about gamma ray. What about charged particle? Now if I put a charged particle, let a charged particle enter this detector, probably nothing will happen. There will be no signal. So this means this detector A is sensitive only to gamma radiation. And to make matters worse, not only just gamma radiation, but also gamma rays close to 1173 or so. Okay. So what we do is that we used many detectors to detect different radiation, and even if we have a single type of radiation but at different energies, say we have a gamma ray at very widely differing energies, then we have to use two different detectors, where one is sensitive to lower energy and another is sensitive to higher energy. But normally such things are quite rare. We use a detector which is quite good enough, or which has good efficiency to detect both the energies. Why? The reason is simple. Detectors are very costly. Good detectors, they cost a lot of money, and we do not have that luxury to buy a lot of detectors for detecting a single gamma ray energy range or so. Okay? Any questions?
স্যার, তার মানে যেটা লোয়ার এনার্জির গামা রে, সেটা ডিটেক্ট করতে আমাদের বেশি সেনসিটিভ ডিটেক্টর লাগে।
হ্যাঁ, আমি ডিটেক্টর লাগবে যেটা ওই রেঞ্জে ভালোভাবে ডিটেক্ট করতে পারে। এই কথাগুলোর আরও আমি ডিসক্রাইব করব ভালো করে। ওকে,
মানে স্যার সেনসিটিভিটিটা এখানে ডিপেন্ড করছে তাহলে এনার্জির উপর, কিন্তু ওটা কিভাবে হচ্ছে?
ওরা আমি বলবো আস্তে আস্তে। I am just talking about the first property only right now. So you see, we are basically, they are designed to be sensitive to certain types of radiation in a given energy range. This is important. আমরা যখন ডিটেক্টর ডিজাইন করি, we design them to be sensitive to certain types of radiation only in certain energy range, since no detector can be sensitive to all types of radiation. Okay?
হ্যাঁ স্যার।
Okay. Now let me proceed forward, and now let me tell you. So you see this detector sensitivity to a given type of radiation and a given, what I am saying, given type of radiation having a given energy depends on, এবার দেখো মজা, what does it depend on? Number one, what is it? The most important thing, দেখো আমি বারে বারে বলছি nuclear reaction. So number one is cross section for ionizing reactions. Nuclear reaction পরে আমি আসছি. Not even that, before that we also need high cross section for ionizing reactions in the detector. Number two is your active mass and volume. and volume of detector. Oita ki? What is that? You say, let me show you. Actually, you can suppose there is a source. I will show you the pictures later on. A detector may look like this, a very big detector, say an HPG detector. It might look so big like this. It doesn't mean that the gamma ray is being absorbed everywhere inside the detector. No, actually the actual material, HPG material, which is the heart of this entire setup, is in a very small place. Now it has to be enclosed specially inside certain containers, and you need a liquid nitrogen diwar to cool this as well. So all this is housed inside this entire big setup. Okay, so এটা ভাববে না যে পুরো জায়গাটাই আমার ডিটেক্টর। নো, ডিটেক্টর ইজ দিস স্মল পার্ট, আর এইটাকে আমরা বলি the active volume or active part of the detector, not this entire setup. The active, normally the active volume or mass is like that of a pencil battery or so, if I am talking about a cylindrical detector. Okay, now number 3 is the inherent detector noise. এই যে আমি একটু আগে বলছিলাম, remember I am just talked about this previously. Here, suppose even before a radiation enters the detector, we always have this sort of thing. So this means there is a noise. Now suppose we have a detector where the noise level is always of this order. Okay, and there our signal enters, which has got just this much height above the noise. What will you say? Okay, you will say that okay, I am getting somewhat usable signal, but it is still not that much reliable because of very high noise. So the fault is that of detector. It has got a very high inherent noise of electrical origin. Next is, you see, the protective material covering the sensitive volume of the detector. Material covering sensitive volume or the active volume of detector. So as I was just telling you right now, the first point basically is the cross section, and you see the detector mass. These two, cross section and detector mass, together they determine the probability that the incident radiation will cover part or all of its energy in the detector into a form of ionization. Now these interaction cross sections are usually much smaller, okay, so that a high mass density and volume are necessary to ensure a reasonable interaction rate. Otherwise, what will happen? Otherwise, the detector just becomes essentially transparent to the radiation. Nothing will happen. Transparent means radiation elo ese chole gelo. Detector is unable to see anything. Note that the mass required depends on the type of radiation and the energy range of interest. This is important. তোমরা বুঝতে পারছো তো?
স্যার
বলো।
স্যার বলছে যদি আমরা হাই এনার্জি ডিটেক্টরের কথা বলি তাহলে সেই ক্ষেত্রে কি ইনহেরেন্ট ডিটেক্টর নয়েজটা খুব একটা মানে রোল প্লে করবে?
সব জায়গায় করবে, সব জায়গায় করবে।
নয়েজটা আসলে বলছিলাম যেহেতু মাইক্রোভোল্ট অর্ডারের হয় আর এনার্জি যেহেতু অ্যামপ্লিটিউডের স্কোয়ারের সাথে প্রপোর্শনাল, দ্যাটস ওয়াই বলছিলাম।
না না না, এটা কোনো যুক্তি নয়। আমি এখন নয়েজ ক্যারেক্টারাইজেশনের দিকে যাইনি। কে বলে দিয়েছে যে তোমার নয়েজ মিলিভোল্ট
হোয়াইট গাউসিয়ান নয়েজের ক্ষেত্রে এটা?
হ্যাঁ হ্যাঁ, আমি ওইগুলো ক্যারেক্টারাইজেশনের দিকে যাইনি, কিন্তু হতেই পারে যে আমার ইলেকট্রিক্যাল অরিজিনের যে নয়েজ আছে সেটা এর থেকে অনেক বেশি, আরও অনেক বেশি। এটা আমার ডিটেক্টর অনেক দিন ইউজ করার পর আফটার এ পিরিয়ড অফ টাইম অফ অপারেশন ওর ভেতরে নয়েজ কিন্তু বেড়ে যাবে। There are various reasons for that. Okay, and that at that time it will just become insensitive. আমি নয়েজ ক্যারেক্টারাইজেশন আমি এখন যাচ্ছি না, আমি পরে পড়াবো, ঠিক আছে? ওকে ওকে আচ্ছা। Now note that even if the ionization here, even if the ionization is produced in the detector, note a small minimum amount is necessary in order for the signal to be usable. This lower limit is determined by the noise, যেটা আমি বারে বারে বলছিলাম, of the noise from the detector and the associated electronics. Remember, when I am saying noise, I am not just saying that the detector is the one culprit, who is the culprit for this noise. No, we are talking about an electrical system where the detector is just the first part. After that, we have to analyze the signal. So there are various electrical and electronic components as well. And you remember as a master's degree student that each electrical instrument, if I use, it will have an inherent, it is a basically inherent source of noise. So after that, there will be noise contribution from all the different components as well. And it might happen that suppose one of the components in the detector system is faulty and it has a very high noise, so as a result of which the entire system will show the high noise. So we have to figure it out as well. Now the noise appears as a fluctuating voltage or current in the detector, as I have just shown you, detector output. And remember, it is always present whether there is radiation or not, and that is its precise nature. This is how we identify noise. A second limiting factor is the material covering the entrance window to the sensitive volume of the detector. Note, আমরা কখনো যে actual active volume of the detector, which is the, say for example, HP detector, we cannot just keep it open. We need to enclose it, otherwise the outside air, atmosphere, I mean all the stuff, there are various elements in the air, they will just degrade the material and it will be unusable very quickly or even after some time. So if I am spending say 20 lakhs over a detector and it just works for say 3 or 4 months, it is just idiotic to even think of buying such a thing. Okay, so this means we need a entrance window strong which will keep the detector safe. But again, if we have a very thick entrance window, then this means that there will be a large absorption in the entrance window, and because of this absorption, only radiation with sufficient energy to penetrate this layer can be detected. So in a way, the thickness of this entrance window material sets a lower limit on the energy which can be detected. So we have got two limiting factors. One is noise, another is the thickness of the detector entrance material. Okay, so we have just now talked about our detector sensitivity. Fine, let me now talk about detector response, which is the next property. So number 2, this is number 1 was sensitivity, number 2 is detector response. Okay, now you see, along with detecting the presence of radiation, most detectors are also capable of providing some information on the energy of the radiation. Let me see an example. Suppose as we are sitting and we are attending this course online, someone knocks on your door, front door of your house. Now this very fact that there is a knocking on the door tells you that someone is there. Okay, so this is the work of a detector. It just detects. Similar, analogous concept. It just detects. Now, if you go near the entrance of the door and see through your eye hole, and you see that there is a lady or a small girl or someone from the Flipkart is there, then this is analogous to a spectrometer. That means right now, after seeing through the eye hole, you are able to say that you are able to give more information about the person who have knocked the door. Now it might be possible that there is no person, some dog is out there playing around and it has come and knocked your door. But even after seeing the eye hole, I am saying, or you have to open the door in that case, then you find out that it is not a person, it is a dog. And if it is a person, whether it is a boy or girl, what age is it, for what reason it has knocked your door, you can find it out after you interact with the person. Right. Now this is what a spectrometer does. A spectrometer, after detecting your signal, it can tell you after analysis. Here the analysis is looking through the eye hole and then trying to understand or talking to the person why he or she has knocked your door and doing the analysis in your brain. Similarly, the spectrometer does this analysis and afterwards it can tell you information whether it is a charged particle, a neutral particle, what energy is it, even it can tell you which direction it has come from. Okay. So as I am saying, along with detecting the presence of radiation, most detectors are also capable of providing some information on the energy of the radiation. Now this follows since the amount of ionization produced by the radiation in a detector is proportional to the energy it loses in the sensitive volume. Now what happens if the detector is very large, such that the radiation is completely absorbed? Then what will happen? So this is your detector, some radiation with energy E, and it has deposited alpha E. Now what happens if alpha is equal to 1 is what I am asking. Then this means that in this case total energy has been absorbed. So the signal that I will be getting will give me a measure of the energy of the radiation. Okay. Now depending on the design of the detector, sometimes this information may or may not be preserved as signal is processed. Now this is quite tricky, but I will explain it later on in the lecture. Okay, so I think right now I have just given you a basic difference between a detector and a spectrometer through a real life example. Okay, now you see in general the output signal of the electrical detectors, the output signal here, is in the form of a current pulse. The amount of ionization is then reflected in the electrical charge contained in this signal. Now, what I mean to say is that the integral of the pulse with respect to time. Now, let us assume that the shape of the pulse does not change from event to event, one event to another event. However, this integral is directly proportional to the amplitude or pulse height of signal. So this characteristic we can use instead. So instead of this integral, we are going to talk about the pulse height, something like this height of the signal, which is a measure of the entire intensity carried by the signal pulse. Okay, so we are going to talk about in terms of the height, pulse height. Now the relation between the radiation energy and the total charge or pulse height of the output signal is referred to as the response of the detector. So what is response? Response, it is basically the relation between the radiation energy and the total charge or pulse height of the output signal. Fine. Any questions till now? Now, let me talk about the third